Good afternoon. I'm going to walk you through a few equations. Hopefully this will help you out with our test tomorrow. I'm going to go through each type of equation: single displacement, double displacement, synthesis, and decomposition, and then we're going to balance them out. First, whenever you start doing these equations, first thing that you want to determine is what type of reaction is it. So here are your four options: synthesis, decomposition, single displacement, and double displacement. The easiest way to tell which type of reaction it is by looking at the plus signs. If you have plus signs on both sides of the equation, like we have in this equation right here, then you're going to end up with some kind of displacement reaction. It's either going to be single displacement or double displacement. The best way to tell if it's single or double displacement is by looking at your first term on the reaction side and compare it to the first term on the product side. Whenever we do this comparison, we're trying to see if any elements have moved out of the term or if any elements have moved into the term. So if we compare C2H6 to H2O, immediately we notice that the carbon has moved out of that equation, and then oxygen has moved into it. So now, instead of having CH, we have HO. And so the C had to move out and the O had to move in. So therefore, since two elements have moved, this is a double displacement. And we'll continue to go through more of these in the other problems. But now let's balance the equation. Whenever you balance the equation, the best thing to do is to get yourself organized. List each of the elements that are on the reactant side and then match them up with the elements that are on the product side. So I have carbon, hydrogen, and oxygen on my reactant side. And I know I'm going to have those same exact elements on my product side. Carbon, hydrogen, and oxygen. Now I just want to count up how many I have on each side. So here I have 2 carbon. C2 gives me 2 carbon. On my product side, I just have 1. There's nothing immediately following the C, so therefore it just tells me that there's only 1 carbon. Now I go to my H's. I have 6 H's, as noted by the subscript 6. So 6 hydrogen. On my product side, I have 2 hydrogen. My oxygen, on my reactant side, I just have 2 oxygen. On my product side, I have 1 oxygen in my first term, because there's nothing following the O, so that tells me that there's 1 oxygen. But I have 2 oxygen in my second term. So I have to add these 2 oxygen together. So 1 plus 2 gives me a total of 3 oxygen. And now I can begin to balance. For me, I always like to start with my odd numbers. If I have an even and an odd number, I know that I'm going to have to make that odd number even so that I can balance out with this other side. So I'm going to start with my oxygen since that's my odd number. There's 3 of them. I have 1 right here and 2 right here. Now remember, I'm working with the odd number, so I need to change this 1. And the best way to make an odd number even is to multiply it by 2. So I'm going to multiply it by 2. Whenever I multiply it by 2, it multiplies not only the oxygen, but it also multiplies the hydrogen in that term. So now I have 4 hydrogen, because 2 times 2, and I have 2 oxygen over here, plus the 2 oxygen in that second term, giving me a total of 4 oxygen. Now I'm going to go over to my reactant side, and I'm going to balance first my oxygen, because that's what I start out with. To balance my oxygen, I just multiply this side by 2, because 2 times 2 gives me a total of 4 oxygen. So now I've got my oxygen balanced. Now I'm going to go on to my other elements. I've got carbon and hydrogen. It doesn't matter which one you go with. Everything's even now, so you just pick whichever one. I'm going to go with my carbon. I have 2 carbon. I only got 1 carbon over here. In order to balance those out, I multiply this side by 2. That gives me 2 carbon, but it also changes the number of oxygen I have. I've got 4 carbon in this term now because 2 times 2, and I have to add it to the 2 carbon over here, 2 oxygen over here. So So that gives me 6 oxygen. So now my carbon are balanced. Now I'm going to go down to my hydrogen. My hydrogen, I have 6 hydrogen on this side, but I've got 4 on this side. Now if I multiply this by 3, it's going to give me my 6 hydrogen, but it's going to make my oxygen odd again. So instead of multiplying by 3, I'm going to multiply it by 6, because I take the 3 that I would multiply by, and I double it. So I keep the numbers even. So instead of having to write a 3 right there, I'm going to write a 6 right there. And that's going to change the number of hydrogen I have to 12. And the number of oxygen I have, I'm going to have 6 right here plus 4 right there is going to give me a total of 10 oxygen. Okay, so now I go to this hydrogen over here. I have to multiply this by 2 to give me the 12 hydrogen, but it also changes my carbon from 2 to 4. So once again, I noticed how everything's coming out of balance again. So I'm just going to go back up to my carbon. I have 4 carbon right here. I need to make this 4. So I have to change this from 2 to 4. That gives me a total of 4 carbon. Because 4 times 1, and it's going to change the number of oxygen I have in this term to 8, plus the 6 right here, gives me a total of 14 oxygen. So my carbon are balanced, my hydrogen are balanced, now I just need to change my oxygen. So right now I've got 14 on my product side. To get it to 14 on my reactant side, I just multiply this by 7, and that gives me 14. It looks like everything's balanced. Now I'm just going to check it. 4 carbon, 4 carbon. Those are balanced. 12 hydrogen, 12 hydrogen. Those are balanced. 14 oxygen, and I have 6 plus 8, so 14 oxygen. Everything's balanced. This is a balanced equation.